Hello students. In this example, we're talking about students who drink Coke and or Pepsi. So we have 25 students that like Coke, 18 that like Pepsi, 9 like neither, and 12 like both. So it seems like they've given us all our information, so let's make a Venn diagram out of it. So I'll make my box, and then I'll have a circle for my Coke, and a circle for my Pepsi. So I'll start with the easiest, 9 like neither, so there's 9 out there, 12 like both, a total of 25 like Coke, so I must have 13 here, and 18 like Pepsi, so I'm going to put 6 here. All right, so let's count up our total number of students. So we've got 13 plus 12 is 25, 6 and 9 is 15, 25 and 15 is a total of 40 students that we're talking about. All right, liking Coke, the probability that a student likes Coke is 25 out of that 40. Liking Pepsi is 18 out of 40. Liking both, 12 out of 40. And now, liking Coke given that they like Pepsi. So given that they like Pepsi means now we're only looking in this orange circle. So I'm now only looking at these 18 students. The ones out of these 18 who also like Coke are these 12. So the probability of liking Coke given that you're someone who likes Pepsi is 12 out of 18. Looking at the other one, we've got the probability of liking Pepsi given that they like Coke. So now we're only looking in this purple circle. So of these 25 people, 12 of them like Pepsi as well. So the probability of liking Pepsi given that you like Coke is now 12 out of 25. So I want you to notice here what sort of patterns that we see. I see on top that my 12 occurs in both my intersection and my givens. In my Coke, Pepsi, and intersection, my denominator was always 40. But now when I had given, my denominator changed, and given Pepsi, it became 18, which was the same as the numerator up here with Pepsi. So here was my 18, and here was my 18 again. When I had my Coke, that was 25, and those 25 people are now down here. So it looks like I could say that the probability, of liking Coke given you like Pepsi, it looks like that's the probability of Coke intersecting Pepsi divided by the probability of liking Pepsi. Well, let's see, Coke intersecting Pepsi was 12 out of 40 divided by liking Pepsi was 18 out of 40. Well, since both of these are out of 40, that out of 40 cancels, leaving me with 12 out of 18. So this comes down and becomes our formal rule for conditional probability. You'll see this in your formula booklet as well. But if I have conditional probability where I've got A given B, so if this is my A and this is my B, well, given B means I'm only looking at the B circle. So if I want A to happen, then that has to happen in here because this is the only space I'll find A inside of what I know happened already. So here's my formal definition, but I can always go back and also use my Venn diagrams to think about what area I'm talking about with my given B.